Welcome to the mathematical highlands, ye brave recruits. I am Clan Commander Algebra, and today ye didn't just sit at a desk like we frightened bairns. Nay, today we march into the grand, epic explainer campaign of polynomial conquest. Look at the battlefield before you. We are going to conquer the division of polynomials. Now, if you've ever felt true fear in your heart looking at a massive, hulking algebraic equation, dinna fret. By the time I am done with you, you will be slicing through variables like a hot broadsword through butter. So straighten your kilts, grab your pencils, because those are your weapons today, and prepare your minds for glory.
Here is the commander's battle plan. We have 3 phases for this campaign. Section 1 is the long division siege. Section 2 is the synthetic division strike. And Section 3, real-world battlefield application. Let us march.
Section 1, the long division siege.
Draw your broadswords, raise your shields, and let out a mighty war cry. This is the heavy lifting, the grueling, glorious, methodical work of mathematical warfare. We are going to take the enemy castle brick by brick. But first, you must ken exactly who is who on this battlefield. Look at the division algorithm before ye. It is absolutely crucial ye know your targets. The dividend? That is the big, ugly polynomial being divided. He sits inside the castle walls, heavily guarded. He is your primary target. The divisor? That is what you are dividing by. He is the heavy weapon you wield on the outside, your battering ram. The quotient? That is a beautiful word, lads and lassies. The quotient is your main answer sitting proudly on top of the castle ramparts. That is your victory banner. And the remainder? That is the leftover debris of the enemy troops. Now listen closely to your commander. If your remainder is 0, that means you struck a perfect tactical strike, a perfect mathematical factor. Let that 0 be your ultimate goal.
To win this grueling siege, ye must memorize the marching cadence, the long division loop. Look at the 4 sacred steps. Engrave them in your mind. Step 1, divide. You divide the first term of the inside target by the first term of your outside weapon. Step 2, multiply. You take that wee answer and multiply it by the whole divisor. Step 3, subtract. And hear me roar now. When ye subtract, ye must flip the signs. Flip the signs like you are ripping down an enemy's shield and throwing it to the mud. If they are positive, they become negative. If they are negative, they become positive. Step 4, bring down the next term in line. Then, you repeat the loop until you run out of terms. Divide, multiply, subtract, bring down. Commit this rhythm to your very soul.
Right then, let us draw first blood. Example 1. We are dividing a second-degree enemy, 5x squared plus 3x minus 2, divided by our battering ram x plus 1. Keep your eyes on the targets. Step 1. Divide. Take your leading target 5x squared and divide it by the leading weapon, x. What do you get? 5x. Send him up to the top ramparts. That is part of your quotient. Step 2. Multiply. Take that 5x and multiply it by the whole weapon x plus 1. That gives us 5x squared plus 5x. Write it underneath the enemy. Step 3. Subtract. Smash their shields. Flip the positive 5x squared to a negative and the positive 5x to a negative. Now combine them. The 5x squareds cancel out to nothing. Dead. 3x minus 5x leaves us with negative 2x. Step 4. Bring down the next enemy, the negative 2. Now the loop begins again. Divide. Negative 2x divided by x gives us negative 2. Put it on the roof. Multiply. Negative 2 times x plus 1 is negative 2x minus 2. Subtract. Flip those signs, warriors. They become positive 2x plus 2. Combine them and bam! 0. No survivors. A perfect tactical strike. The quotient is 5x minus 2 and the remainder is 0. Now it is your turn. Interactive battle check. Try it number 1. Grab your pencil, run the loop on x squared minus 5x plus 6 divided by x minus 2. Do it now and claim your glory.
You have tasted victory, but now the enemy escalates. Example 2. A massive third-degree beast, 6x cubed plus 11x squared minus 31x plus 15. And our weapon is messy this time, 3x minus 2. Form up the shield wall, we go in. Divide. 6x cubed divided by 3x is 2x squared. To the top with him. Multiply. 2x squared times the whole divisor gives 6x cubed minus 4x squared. Subtract, flip the signs. It becomes negative 6x cubed plus 4x squared. Combine, the cubes die, and 11 plus 4 gives 15x squared. Bring down the negative 31x. Loop again. 15x squared divided by 3x is positive 5x. To the roof. Multiply. 5x times the divisor gives 15x squared minus 10x. Subtract, flip the signs. The positive 15 becomes negative, the negative 10 becomes positive. The squares die, and negative 31 plus 10 is negative 21x. Bring down the positive 15. One last strike. Negative 21x divided by 3x is negative 7. To the roof. Multiply. Negative 7 times the divisor gives negative 21x plus 14. Subtract. Flip the signs to positive and negative. The x's die. 15 minus 14 is 1. Ugh, a remainder of 1. We have a surviving wee enemy soldier. But we didn't just let him go to fight another day. Nay, we trap him in a fraction cage. The final answer is 2x squared plus 5x minus 7 plus 1 over the divisor of 3x minus 2. Put him in the cage. Interactive battle check. Try it number 2. Can you take down the third-degree beast on the right? Charge.
Section 2. The synthetic division strike.
Stand down, warriors. Wipe the sweat from your brow. Ye have mastered the heavy broadsword of the long division siege, but now put away the heavy armor and wrap yourself in shadow. I am going to teach you a secret, stealthy ninja attack that will let you bypass the grueling siege entirely. Behold the ultimate shortcut, synthetic division. Look at the elegant setup before you. It is deadly, but beware, it only works when you are dividing by a simple linear factor like x minus c. Here is how you set the ninja trap. First, look at the box on the left. If ye are dividing by x minus 3, you put a positive 3 in that box. Hear me well, ye always flip the sign for the root. Next, the top row. No more messy variables. You just extract the pure coefficients of the dividend and line them up. And finally, the bottom row will magically become your new answer coefficients. The ancient kata for this strike is simple. Drop down, multiply diagonally, add vertically. Let us see it in action.
Example 3, a fast-paced stealth strike. Divide 5x squared minus 3x minus 36 by x minus 3. Look at the setup. The divisor is x minus 3, so we flip the sign and put a positive 3 in the box. Line up the coefficients. 5, negative 3, negative 36. No variables to bog us down, just pure lethal numbers. Now execute the kata. Drop the 5 straight down to the bottom line. Now multiply diagonally. 3 in the box times 5 is 15. Put it under the next number. Add vertically. Negative 3 plus 15 is 12. Multiply diagonally. 3 times 12 is 36. Put it under the last number. Add vertically. Negative 36 plus 36 is 0. Bam! Strike complete. The remainder is 0. Now to reattach the variables, you just drop 1 degree from the original. It started as x squared, so our answer starts as x. The final answer is 5x plus 12. So fast, you barely saw the blade move. Interactive battle check. Try it number 3. Execute a stealth strike on 2x squared minus 3x plus 9 divided by x minus 3. Be swift.
Let us strike again. Example 4. A third-degree polynomial, 4x cubed plus 10x squared minus 6x minus 20 divided by x plus 2. Quick now, the divisor is x plus 2, so we put a negative 2 in the box. Line up the coefficients, 4, 10, negative 6, negative 20. Execute. Drop the 4 down. Multiply. Negative 2 times 4 is negative 8. Add. 10 minus 8 is 2. Multiply. Negative 2 times 2 is negative 4. Add. Negative 6 minus 4 is negative 10. Multiply. Negative 2 times negative 10 is positive 20. Add. Negative 20 plus 20 is 0. Another perfect strike. Look at the bottom row. 4, 2, negative 10, 0. Since the original enemy was x cubed, we drop down 1 step. The answer starts with x squared. Final answer, 4x squared plus 2x minus 10. Magnificent. Interactive battle check. Try it number 4. See if you can stealthily slice through x cubed minus 2x squared minus 9. Hold the line. Hold the line. Look at example 5. Divide negative 9x to the 4th plus 10x cubed plus 7x squared minus 6 by x minus 1. Panic on the battlefield. Look closely at the dividend. 4, 3, 2. Where is the x to the power of 1? There is no x term. It is a trap. A gap in the enemy line designed to break your formation. If you just write down the numbers as they are, your whole strike will fail and we will be routed. But ye are smarter than that. ye must confidently deploy a wee dummy soldier, a 0. We use a 0 as a placeholder for that missing x term so the line does not break. Look at the top row setup, -9, 10, 7, 0, -6. The box gets a +1, let us strike. Drop the -9, multiply to get -9, add to get 1, multiply to get 1, add 7 plus 1 to get 8, multiply 1 times 8 to get 8, add 0 plus 8 to get 8, multiply 1 times 8 to get 8, add -6 plus 8 to get 2. The remainder is 2. Since we started at x to the 4th, we drop 1 degree. Final answer, -9x cubed plus x squared plus 8x plus 8 plus 2 over x minus 1. We survived the trap. Interactive battle check. Try it number 5. Deploy your own dummy soldiers if you need to.
Section 3. Real-world battlefield application.
Ye have survived the grueling siege and mastered the shadows of the stealth strike. Come into the armory, surviving soldiers. It is time to review our weapons and see how these ancient algebraic tactics are deployed in the physical world of 3D geometry. What good is a warrior who cannot build a fortress, eh? First, a showdown. Which method do ye use in the wild? Look at your choices. On the left, the heavy broadsword of long division. When to use it? Any time. It is your reliable heavy lifter. Best for messy, complicated divisors like 3x minus 2. The vibe? It takes up space, it is a lot of writing, and your hand will cramp, but it always gets the job done. On the right, the throwing star of synthetic division. When to use it? Only for simple linear divisors like x minus c. It is highly specialized. Best for speedruns and quick checks for perfect factors. The vibe? Super fast, minimal writing, but you must remember the strict rules. Choose your weapon wisely.
Example 6. Look at this massive rectangular box. The volume is x cubed plus 5x squared plus 6x. The length is x plus 2. The width is simply x. But the height? The height is missing. To conquer this geometric puzzle, we must use our division weapons. The formula for volume is length times width times height. Step 1. Let us divide the volume by the simplest piece, the width, which is x. That is an easy strike. X cubed plus 5x squared plus 6x, all divided by x, leaves us with x squared plus 5x plus 6. Step 2. Now we take that result and divide it by the length, x plus 2. Let us use our stealthy synthetic division. Put -2 in the box. Coefficients are 1, 5, and 6. Drop the 1. -2 times 1 is -2. 5 minus 2 is 3. -2 times 3 is -6. 6 minus 6 is 0. The quotient is 1 and 3, which means x plus 3. The missing height of the fortress is x plus 3. We have conquered the third dimension. Interactive battle check. Your turn number 6. The area of a rectangle is 3x cubed plus 14x squared minus 23x plus 6. The width is x plus 6. Find the length. Go.
And now, brave lads and lassies, we have reached the end of our campaign. But the war is never truly over. Behold the final boss. Level up your practice. I command you to choose your weapon, the broadsword of long division or the throwing star of synthetic division, and conquer these final boss problems on your own. A is a long division focus, B is a synthetic division focus, and C is a glorious application focus to test your architectural might. I have given you the tools, I have taught you the marching cadence, and I have shown you the way of the ninja. Now it is up to ye. Will ye retreat, or will ye conquer the polynomials? Dive into these problems and claim your ultimate mathematical victory. As ye leave this battlefield, ask yourself this. If the language of polynomials can uncover the hidden heights of a fortress, what other invisible dimensions of our universe are just waiting for ye to decode them? Until the next campaign, hold the line.